Imagine standing on a cliffside. All you see is rock, grass, and the Pacific Ocean stretching to the horizon. Then a door opens. In the cliff face in front of you, behind it, is a 12,000 square foot home. This is not science fiction. This is what money can do today.
By the time you finish watching this video, you'll have a complete understanding of how the world's most extraordinary homes are designed, where they're built, and the engineering behind them, giving you the inspiration and the knowledge to create your own dream home.
But before we get to the homes themselves, the price tags, the controversy, the engineering that defies logic, we need to understand one thing first. How do you actually make a building disappear? Because this isn't just about aesthetics. This is an entire design philosophy, and it has a name. Architects call it landscape integrated design. The idea that a structure should not compete with its natural environment, but submit to it. For decades, luxury meant imposing. You built tall. You built glass. You made sure people knew something extraordinary was there. But a shift happened, driven largely by a group of ultra-wealthy clients who wanted the opposite. They didn't want to be seen. Not for privacy reasons alone, though that's part of it. They wanted their homes to feel like an extension of the landscape itself, like the terrain had simply been sculpted into a living space. Earth-sheltered homes had been exploring this idea since the 1990s, but it was projects like Field Architecture's Big Sur Cliffside House, completed in the 2020s, that pushed it to its absolute extreme. And achieving that requires two completely different types of architects, working in an unusual order, which is where it gets interesting. Most homes are designed by a structural architect first, someone who figures out how the building stands up. And then a landscaper comes in at the end to plant a few trees around it. For landscape-integrated homes, that process is completely reversed. The landscape architect comes first. They study the cliffside, the rock formations, the natural drainage patterns, the way light hits the terrain at different times of day. Only after that analysis is complete does the structural architect begin designing around the landscape, not on top of it. The result is a building that feels like it was always there, like nature drew the blueprints. So what are the actual techniques that make this possible? The first is earth-sheltered construction. The home is partially or fully buried into the hillside or cliff. The roof becomes the ground. Grass grows over it. From above, from a boat, from a neighboring property. There is nothing to see. The second is reflective glass facades. Floor-to-ceiling glass panels that mirror the ocean and sky around them. Stand at the right angle, and the building reflects its environment so precisely that your eye simply skips past it. Third, living roofs. Layers of soil, drainage membrane, and native vegetation planted directly onto the roof line. These aren't decorative. They add structural ballast, support local wildlife, and in some cases, the surrounding ecosystem doesn't even register that a building exists beneath them. And fourth, weathering steel, also known as Corten steel. It rusts deliberately. Over time, it takes on the exact color and texture of surrounding rock. Pair it with the right stone cladding, and a wall that costs $2 million becomes indistinguishable from the cliff it's anchored to. Now, here's what most people don't consider. These homes have to survive. A building that disappears visually still needs to withstand coastal winds, saltwater corrosion, and wave impact forces that can exceed 2,000 pounds per square foot during a major storm. So beneath the grass rooftop and the mirror glass and the rusted steel, there is reinforced concrete, marine-grade structural systems, and foundation engineering that in some cases goes 40 to 60 feet into bedrock. The invisibility is on the surface. The engineering underneath it is anything but subtle, so the techniques exist. The philosophy is clear. But where are these homes actually built? And who is building them? Let's go. Location by location. The California coastline is arguably where landscape-integrated design reached its purest form. Big Sur sits on one of the most protected and legally restricted coastlines in the United States. Coastal Commission permits are notoriously difficult to obtain, which means the homes that do get built here are the result of years, sometimes decades, of legal, architectural, and engineering work. Field Architecture's Cliffside House in Big Sur is one of the most studied examples in the world. Anchored directly into rock, its walls clad in quarried limestone, cut and faceted to mimic the natural bluff face, it disappears against the coastline so completely that it reads as geological formation rather than structure. FSC certified timber handles the interior warmth, but from the outside, the cliff simply continues. Cost estimates for builds of this complexity in Big Sur routinely run $20 to $40 million, and that's before factoring in the permit battles, the remote logistics, and the custom material fabrication. These aren't just expensive homes. They're expensive problems that only money can solve. Move to the Indian and South Pacific Oceans, and the disappearing technique changes entirely. Here, the challenge isn't blending into a cliff. It's building on water and making the structure feel like it belongs to the ocean rather than sitting on top of it. Ultra-high net worth private villa developments in the Maldives and Bora Bora use low-profile overwater platforms, glass floor panels, and submerged lounging areas to dissolve the boundary between structure and sea. Concrete pillar foundations are engineered specifically to minimize coral disruption beneath the waterline. Private villas at this level, fully custom, remotely located, with full staff infrastructure, carry estimated price tags between $15 and $50 million. Several remain unlisted and unphotographed by design. Norway presents a completely different engineering problem. The landscape here isn't a cliff you build against. It's a vertical rock face, dropping straight into freezing water. Firms like Snøhetta, one of Scandinavia's most commissioned architects for extreme terrain, have pioneered designs perched and nestled into fjord walls rather than placed on top of them. Their boulder cabin in Fjorden sits on concrete pillars with expansive glass, achieving near invisibility through material palette alone. Dark timber, raw concrete, and black steel make these structures absorb the landscape rather than interrupt it. Construction costs in remote fjord locations are significantly inflated by access. Materials must arrive by boat or helicopter. Estimated project costs in this category typically run $10 to $30 million, though remoteness alone can double standard build costs. At the southern edge of the world, Australian architects have built a reputation for what the industry quietly calls bunker estates. These are oceanfront properties built low, heavy, and into the earth. Concrete berms, subterranean entertaining floors, stone cladding chosen to echo the surrounding cliffs. Their Water's Edge project in Sydney is a textbook example. Lowered into the landscape, its roofline barely cresting the coastal scrub above it. SAOTA has delivered completed estates across Australia and beyond, with projects on 4 continents, and estimated values between $25 and $60 million. Their signature remains consistent. maximum ocean exposure from inside, near zero visual footprint from outside. And across all of these locations, certain names keep appearing. Tadao Ando, the Japanese Pritzker Prize-winning architect, whose concrete minimalism has become the language of billionaire restraint. Kengo Kuma, whose philosophy of erasing architecture has made him one of the most sought-after designers for clients who want presence without visibility. And SAOTA, whose coastal work across 4 continents has essentially defined what extreme oceanfront living looks like in the 21st century. These aren't just architects. For a certain class of client, they are the difference between a very expensive house and a home that becomes part of the earth itself. So now you know what these homes look like and what they cost. But there's a question that most coverage of these properties completely skips over. How do they actually stay standing? Because building into a cliffside, over the ocean, or into a rock face isn't just an architectural challenge. It's a war against nature. And the engineering required to win that war is, in many ways, more impressive than the design itself. The first enemy is salt. Saltwater air is one of the most corrosive environments on the planet. Standard steel corrodes within years. Standard concrete absorbs moisture and cracks. Even standard glass degrades under constant salt spray exposure. So every material in these builds is either selected or treated specifically for marine environments. Structural steel is galvanized or coated with epoxy barriers. Concrete uses a higher cement-to-water ratio with silica fume additives that seal the internal pores. Glass panels are marine-grade, tempered, laminated, and framed with aluminum or composite systems that don't react to salt. Nothing that touches salt air in these homes is an off-the-shelf material. Everything is specified, tested, and in many cases, custom manufactured. The second challenge is the ground itself, or the lack of it. For homes built directly over water, engineers use deep pile foundations, steel or concrete columns driven 30 to 60 feet into the seabed, designed to absorb not just the weight of the building, but the lateral forces of waves and tidal movement. For cliff face and rock-anchored builds, the technique shifts to rock bolting, high-tension steel anchors drilled directly into bedrock, sometimes at angles, creating a network of tensioned connections that ties the structure into the geology itself. In both cases, the foundation work often costs more than the visible structure above it. Then there's the question of what happens when a serious storm arrives. Wave impact forces on exposed coastal structures can exceed 2,000 pounds per square foot. These homes aren't just built to current weather patterns. They're engineered against projected worst-case scenarios using coastal hydrodynamic modeling. Physical scale models are sometimes tested in wave tank facilities before a single foundation bolt is placed. Structural frames are designed to flex, not just resist, because a rigid structure hit by that kind of force doesn't hold, it shatters. Now add another layer of complexity. These homes are also fully automated. Climate control, security systems, retractable facades, automated storm shutters, lighting, water management, all of it runs through concealed infrastructure that cannot compromise the minimalist aesthetic. There are no visible conduit runs, no exposed cable trays. Every system is routed through structural cavities, designed into the build from day one. Some of these properties have more concealed technology per square foot than a commercial data center. And then there's the unglamorous side of remote coastal living. These properties are frequently miles from municipal water and sewage systems. So, they engineer their own. Rainwater harvesting systems fed into underground cisterns, gray water recycling loops, advanced aerobic septic systems that process waste on site, to levels clean enough to discharge near coastal water bodies without environmental violation. The infrastructure beneath these homes is, in some cases, more sophisticated than the systems serving entire small towns. Finally, getting permission to build any of this. Coastal construction in most countries triggers some of the most demanding permitting processes in existence. Environmental impact assessments must account for marine habitat disruption, coastal erosion acceleration, stormwater runoff, and visual impact from the water. In California alone, Coastal Commission approval for cliff face projects can take 3 to 5 years and cost hundreds of thousands in consultancy fees before a shovel hits the ground. Billionaires don't bypass this process. They simply hire the legal and environmental teams large enough to navigate it and absorb the timeline. So what does a home like this actually cost to build? The numbers are staggering, but more importantly, they're staggering in ways most people don't expect, because the sticker price of these properties is rarely the most shocking figure. It's everything underneath it. Standard luxury construction in a major U.S. city runs roughly $500 to $800 per square foot. High-end oceanfront luxury, think Miami Beach or Malibu, pushes that to $1,500 to $2,500 per square foot. Ultra-luxury landscape integrated coastal builds, the range starts at $3,000 per square foot and has no real ceiling. A 12,000 square foot cliff face home at that baseline figure is a $36 million construction cost. Before land, before design fees, before the years of permitting we just discussed. Based on reported projects, the most extreme examples in Big Sur and private island builds in the Maldives have reached $4,000 to $6,000 per square foot in total project costs. And that's construction only. Factor in soft costs like design fees, permitting, and the true total runs another 20 to 50% on top. Everything we've covered so far is remarkable. The design, the engineering, the sheer financial scale of these projects. But there's a conversation happening around these properties that goes far beyond architecture, and it's getting louder. And some of these projects have ended up in court. In Australia, New Zealand, and parts of the EU, coastal preservation laws have become increasingly aggressive, and the legal exposure for non-compliant luxury builds has grown with them. Then there's an irony that the architectural press has largely begun to reckon with, even if slowly. These homes are being built on coastlines that climate science projects will be fundamentally altered within the lifetime of the structures themselves. And the impact isn't only environmental. Coastal land acquisition at this scale drives property values along entire stretches of coastline, beyond what local communities can sustain. Fishing villages, small coastal towns, and indigenous communities with generational ties to specific coastlines, including Maori communities in New Zealand, and long-established residents along the Malibu coast, have been progressively priced out. Finally, the carbon cost. The construction of a single ultra-luxury coastal home of this scale generates an estimated 2,000 to 5,000 metric tons of CO2 equivalent, roughly equivalent to 40 to 60 years of a single American's total carbon output. Helicopter material deliveries, custom concrete pours, marine-grade steel fabrication. Remote logistics can double the carbon load of an equivalent inland build. And then the property runs indefinitely. Off-grid locations rely on diesel generation and fuel shipments, with annual energy consumption in some cases exceeding that of a small commercial building. So here's where we land. The tension isn't really between billionaires and the rest of us. It's between what human ingenuity can build and what the natural world can absorb. Which is why I want to know what you think. Because there's no clean answer here. These homes are breathtaking. The engineering behind them is genuinely remarkable. If this video made you think differently about what luxury actually costs, hit like. Subscribe if you want more of this. We go deep on the stories behind extreme wealth, extreme engineering, and what happens where the two collide. And drop your answer in the comments. Would you live in one of these homes? And if you have a story or a topic you think deserves this kind of breakdown, tell us. The best ideas for this channel, the boy were below, have always come from down there.